Hi everyone, one more time. Добрый день. Welcome to our AI marathon from GlobalLogic Education. This marathon is a series of free knowledge sharing webinars designed by our GlobalLogic experts to share their expertise to boost your skills in dealing with AI issues. And today is our first webinar, so we are very glad to see you joining, and we hope you will enjoy today's evening. I need to go to the next slide. So before we start, I would like to introduce you our agenda. And traditionally, we will start with overview of our GlobalLogic company. For those who join us for the first time, want to remind you a little bit. Then I will switch to program details and webinar communication rules. Then I will pass the word to our today's speaker. And after the lecture, you will have opportunity to get answers to your questions, which we will ask you to text in the Q&A panel in Zoom. And at the end, we will share with you our contacts for further communications, proposals, or if you have some questions to ask. So let's get started. About GlobalLogic company. GlobalLogic is one of the leaders in digital product engineering, and from 2021, the company is a part of Hitachi Group holding, and it enhances Hitachi Group strategy to build innovative business which will serve society and clients' needs, especially by creating cloud platforms and in a lot of crucial important spheres for Hitachi. Also, GlobalLogic is a very huge company. It has approximately 30,000 of engineers from all over the globe. One of the biggest hub is Europe, but GlobalLogic is also presented in India, Argentina, USA, and other countries. And such wide marketing diversification helps us to be closer to the customer and also to have like local specialties. For example, in Europe, we are highly specialized in embedded engineering and as well as in automotive sector. In India, for example, we have strong mobile application industry and other peculiarities of our business. The next slide. Also, GlobalLogic is not only geographically spread company, but also our business partners with customers from a lot of spheres, automotive, financial sphere, healthcare, media and entertainment, and a lot of others. So we make daily interactions of our customers more innovative, comfortable, and more easier to perform. So that was all about our company. If you want, you can study more at our GlobalLogic website. And some words about today's AI marathon. We created it to make all of you benefit from our lectures, and we hope that you will gain not only foundational knowledge, but also some practical skills, which we will share with you. And also one of the benefits is that we created some bonus for you, for those who will fill the feedback form, which we will send at the end of the webinars. We will design for you online certificate of participation after the all webinars. Here you can see our program. Today is our first artificial intelligence lecture, but I'm sure that you have been acquainted with our program on our website. And also this Zoom link, which is active for today's lecture, it will be valid for all the next webinars. So this is the single Zoom link, and you can use it for each webinar. And some communication details. We highly encourage you to put your messages related to, I don't know, some greetings, chatting with other participants in chat block. But if you want to leave question to our speaker, please text it in Q&A panel. So Q&A panel for questions to the speaker and chat block for messaging with others. Today I will moderate this webinar, so if something will go wrong, I will manage it, I will text you, I will answer you in both chat and Q&A block. Also, we highly ask you to be respectful while communicating, and I want to remind you that you will receive recording of this lecture. It will be sent to your email, but approximately within 5 business days after this webinar, because we need some time to work with the recording and some our internal issues. And also remind you about possibility to receive a digital certificate after the last webinar. We will send you a feedback form to fill and in order to receive this certificate. So that's all from my side. I think that I can pass the word to our today's speaker, Vitalii Miroshnychenko, who is GlobalLogic leading engineer and has more than 8 years commercial experience in different IT domains. So Vitalii, I think that the floor is yours and you can share your presentation.
Okay, so now you should see my screen.
Yeah,
let me introduce myself. My name is Vitalii Miroshnychenko. I am lead engineer in GlobalLogic with more than 8 years of experience. And also I am Ph.D. in statistics. So we will see several formulas from mathematics today, but it is not necessary for you to know all of them. So let's start. Nice to see you all here. And today I'm going to talk about artificial intelligence, about its past, present, and future, and even more. For today, I would like to review AI history. Maybe not all parts of them, maybe the most important parts. The second theme is application AI in tech directions. In other words, how we can use generative AI in our routine work. The third theme is about AI developer. What are tasks of the AI developer, who is it, and how to become. And fourth theme is successful projects. And the last thing, it is about the future of AI in our life. So let's start from the history. And as I said, I'm going to show you several slides with formulas. This is the first one. And later we will have one slide more. Almost all cool things in IT started from mathematics, and AI too. AI starts from mathematical statistics, from statistical learning, and this field was discovered maybe 100 years ago. In this form, when we have data, for example, species characteristics or object characteristics, and we want to know about other features of the objects or other features of the species, or if you have knowledge about customers in our store, we want to predict how much money they will give us. much items they will buy, or how many items we will sell. So there was created a very simple model, linear regression. But even with this model, we can build the simplest AI here. We have all necessary concepts. We have data. We have data model where targets are dependent on regressors or features. We have unknown parameters, and we have noise. Noise that we cannot, we can fit, but we shouldn't fit on the noise. And one more concept that we need here is loss function. For example, in this example, we want to make the variance of the noise is as minimal as it possible, but not minimal on training data set, on testing data set, on data that we will see in future. So we have all necessary concepts: data structure, and loss function. And even more, we should have the procedure that will fit our parameters. So from the mathematical perspective of view, each AI algorithm, it is this formula. It is looks like this formula when we have unknown parameters b. So we need to fit them. That was a beginning. Later, in 1999, there was created a gradient boosting algorithm. I'm not going to tell you about all steps. Yeah, before this algorithm, before gradient boosting, there were algorithms based on decision tree. And decision tree, it is algorithm for regression or classification for each object that can divide all objects from our sample on subgroups, and for different subgroups, predictions will be different. For example, this if we talk about loans, this algorithm split all population on subgroups, and for different subgroups, it can tell us whether they give us money or they fall, or we not take money back. So this was the first very powerful AI algorithm based on decision trees, and it's used even now for some problems, for some simple problems, or not even simple, it is used. The next step, maybe the second important step, was development of artificial neural networks. Jan LeCun in 1989 till 1998 created the first convolutional network, as we know in a current state. He used backpropagation, he used convolutional layers, he used feed-forward layers, and he created the simplest neural network for image classification. He take many different numbers written on the paper, and the goal of the neural network was to classify each image and tell what number is represented. This is the second most important algorithm discovered in previous millennium, and till now, paradigm is still the same. We use non-parametric models like gradient boosting, or parametric models, but very huge parametric models like neural networks. The next step of the development of the AI is based on contemporary neural networks, on convolutional neural networks. Yeah, before 2012, there were many good cases or many developments, but they were not productionized. only researchers used them in the algorithm, or big companies used inside their IoT devices like smartphones or mobile phones and so on. This technology was not in public. And roughly from 2012, at ImageNet competition, guys created a neural network slightly bigger than LeNet, than neural network from previous slide. It has only two convolutional layers, and AlexNet have only 5 convolution network. And what is an update? Update we have because in 2011, Google created TensorFlow library. So at this time, humanity created many frameworks to design and fit neural networks, and even optimization algorithms. First of all, TensorFlow, PyTorch, and other libraries, they are optimization frameworks. And in the second step, they are they give us suitable blocks to build neural networks. So from 2012, they were discovered and created thousands of different architectures. But most important are VGG, developed in the 2015, GoogleNet or Inception. At the same year, ResNet. And the difference between them is not big. Generally, they use convolution layers and dimensionality reduction by pooling algorithms. And the idea is to make image as smallest as it's possible, but make the information suitable for algorithm to classify or to predict something. And the next steps, how we can upgrade neural networks, not build them sequence by sequence, block by block. We can create a block of blocks or blocks of layers and then combine Z blocks. In 2007, they were discovered architecture ResNet, where input from previous layer go to next and after the next layer. And it increased dramatically training of the neural networks. And because of this trick, we can feed neural networks for 1 or 2 days, but not for 1 and 2 months. And maybe the most interesting architecture from this period is DenseNet, developed in 2018. It is contains of blocks that connected from each previous blocks, and inside each block, all sub-blocks are connected. So this is a very interesting idea, very cool idea, and these neural networks, they are too big, but it represents the problem of this approach. Just mixing the blocks and connecting them will not give a better result. If you read some papers, DenseNet is not used. Humanity took LeNet, humanity took ResNet, and we are trying to upgrade these two architectures because they simpler than other architectures, but powerful enough. So this was the second etap, the second stage of the development, and the last stage of development it started at 2017 and goes till now, and it starts from development of multi-head attention mechanism. when we can where we use just simple matrix multiplication several times, but with special weights, we can receive new features and describe text even better than previous architectures. Or we can even use this approach to describe image, to solve problems of classification, detection, segmentation, even better than if we use convolutional network. Here's an example. The left part, it is a BERT architecture taken from article, All You Need is Attention. And the second part of the screen describe visual transformer that use idea from that article, where we image split on sub-images. This sub-image goes to the encoder, and then those encoded image go to transformer, to this block. And this approach give us a very cool result. The latest architectures, almost all of them are based on attention model, or they are transformers. Let's see on the best result. I showed you today problems that almost solved for today. And the biggest problem for this problem that data set are bad. It was not obvious till the end of previous decade, till this decade. But when we fit many models, we increase the quality of the model. We see that there are many bad examples, or we cannot believe human when they access the image. For example, here we see car, but the answer is grill. Here we see mushroom, but answer is agaric. Here we see a dog and a cherry, but neural network tells us that it is a dog, but the true label is a cherry, and so on. So the current state of all AI is that we cannot. The biggest problem that the data set are not ideal. And some companies solve this problem and their data set are public. We will talk about them later. So the first fixed problem is classification of the images. Generally, we will talk about AI for image processing. The first problem is classification. We need to, for each image, tell what object is in the image. A bug, a sheep, motorbike, a cat, and so on, leopard. And this problem is almost solved. There are many good architectures like visual transformers that work very well, better than even the human can solve this problem. And we faced with dataset quality problem for this task. The next solved problem is the detection. And the problem roughly the same, but even more. Guys who solve this problem every day know that there are many problems with labels. Sometimes not all objects marked by accessors, the human who create a markup for images. And overfitting is very big problem here too. And we do not even now know how many objects we should show for each image. For example, if we look here, we see only 2 people. But if we see the crowd, we do not know, should we display all human or only some of them? But anyway, this problem is almost solved. I talk almost because there are many applications, there are many problems for which we should create data set from the beginning and feed it one more time. So the problem which we have here, it's additional that we probably want to use previous architectures and knowledge extracted from previous models and use them as a tutor for new models or knowledge reusement. One more solved problem, it is a segmentation. Meta have created many neural network architecture. Detectron is one of them. And this model it covers almost all image body classes, human, bug, bicycle, and so on. And even more, it can return us a polygon of the image or just square, and return the skeleton or pulse of the human. And one more cool model is visual transformer based on dataset segment anything from Microsoft. This is one of the biggest and well done dataset for segmentation problem. And all you need is just to have many graphical cards to process this data and feed your models. You can even see this car is completely filled by classes, by labels, and humans are filled by labels. So this is a very big data set. There are trillion of these markups. What problem is almost solved? The next problem is text generation. Many of you maybe use ChatGPT or other related technologies like Copilot, Llama, Gemini, and so on. We believe that large language models behave or can type good text or behave like human, but there are many problems with censorship. There are many problems with the quality of response, because only subject matter expert can tell you is the answer good or not. For example, I faced with this several times when prepared for my lectures for students. We cannot trust the mathematical answers from ChatGPT because he knows well-known problem like Big Fermat theorem. But if I ask him to prove some axioms, for example, Euclid's axioms, it will fail. It will create something that it's called proof, but it's not proof at all because it used wrong logic. It is not used logic. But we believe that this problem is solved and models become better and better. What problems are solved today? I show you a demo of the closed project. Atlas. It is a bot. It contains a neural network inside, and this neural network was fed on millions of simulations in simulated worlds. And this technology can work. Maybe you saw Boston's other projects. They are very cute, they behave well, but project is closed because technology is outdated. They have even better technologies. What else we have right now? Deepfakes is solved. We have faced with deepfake singularity. Now we can create fake faces, fake voices, fake moves, fake movies, fake text. Almost everything can be fake. And president and parliament elections in India show us them. due to newspapers, parties at India use a lot deepfakes for black marketing of their opponents. So this is a very big problem because India one of the biggest democracies in this world. Probably in future we will face with this problem too. What problem solved too? Multimodal model, they are very cool. Now we can create image by text. DALL-E 2 maybe outdated architecture. We know even better models. And they, how we use them? We type a text and the model generate an image due this text. For example, oh, I forgot to add here Midjourney results. They are even better, but I have Midjourney in the end. What else? One more cool thing that is solved is image to image that use generative adversarial networks and diffusion. And the idea of such models is they are different. The first idea is to create a markup and fill the image by markup. For example, Photoshop has shown the technology called palette. Oh, sorry, no, Google showed palette. And Photoshop has this feature too. And they use generative adversarial networks and diffusion models to create photorealistic landscapes or realistic images. This problem is solved too. You see a lot of generated image in Facebook, in Instagram, in Reddit, and other sites, and moreover, many sites and social network limited using of AI-generated image, because there is a statistic that for last 5 years, humanity creates more, using AI, created more information that was used, that we produced for last 2000 years. So amount of data is very huge. Let's talk about AI in production, how we can use it in our everyday task or in our routine. The first step is AI for developers. But not only for developers, for students too. This week I read many laboratory works from my students who gave me a code from ChatGPT. The goal of the student, the goal of laboratory work was to feed simple models to predict heart diseases. And some of them used ChatGPT to create code for them. I show you an example. And students did the same. They just write, let X are features and Y are targets, please generate me a train test split, and so on, and fit on my data. And Copilot and ChatGPT very well create this code. This is an example from Copilot. Result is fascinating. This is a cool code for laboratory work, but almost all problem in real production, it will not fit, because data is more complex. How we can use this else? We can use it to create testing codes, to parse, for example, MAC addresses, RPD addresses, and create regex. Copilot and ChatGPT creates very good code for this. How we else use ChatGPT? We ask, for example, ChatGPT or other things like Copilot to create a documentation for us or create a text or intro text for a presentation. And sometimes result is shitty, but sometimes result is good. Every time we need to read almost each word. Why we need to read each word? Because these large language models, they are not predictable. We do not know what will be the next, what phrase will be the next. We believe that it's stable, but truly it is not. For example, I asked it to write me intro about generative AI MLOps project, and the neural network thought that Gen AI, it is the name of the project, and MLOps. You know that MLOps is a paradigm, but he doesn't know about Gen AI. Gen AI topic is developed later than data. This topic was developed later and was not included in ChatGPT's training sample. So we need to read all our text. How else can developers use generative AI? We can ask him to write some very complex and hard algorithm. For example, I'm working with article about colony algorithm for traveling salesman problem. And I know there are many examples in the internet, but for example, I asked Copilot to write this code for me, and it's done this work. But unfortunately, I'm not specialist in algorithms. So I need to check these algorithms. So I need a data set to check this, the result of this code. To check on compilation, to check on the right answers. So without data set, you cannot tell that the problem is solved and code is good, because if you are not subject matter expert, you do not know where's the problem, where's the mistake. So please be careful with generated code. How we can use else? Support engineers can use such type of models for resolving common problems, and even more not common. In my company where I work, I constantly faced with Docker problem. Docker, it is a software that allows to create virtual computers on my computer. And time after time, I have IP conflict in my laptop. So I asked ChatGPT how I can fix this problem. And if it gave very cool answer. And answer is right. This is the most interesting, that all steps here are correct. First of all, we need stop service. We need to open the file with IPs. We need to fill it. We need to save it and start the Docker. And only then see the current state of the service. And this thing works. It works because I did this several times. And even more, we can ask more hard problems. But unfortunately, for very rare problems, it will not give a good answer. It gives suggestions, and other people also tell you suggestions, and rare problems couldn't be fixed using only generative AI. For example, if you have several virtualization layers and you need to make a pass-through of the graphical card through all virtualization layers, be sure that ChatGPT do not understand you. Probably you do not understand me too when I talking about several virtualization layers, and it is normal. Okay, one more interesting problem, what we can solve, it is a testing. For example, when we need to create a test for our code, we can put the code here, or ask the common problems, and ChatGPT and Copilot can generate code for us. ChatGPT very well created a testing code for list in Python. It it tests initialization, but it be very please keep attention here. It created code not to test a list object. It created a good set of tests, but inside it tests Python list. We do not need to test Python list. We know how it works. Here we should place our data structure. But what I see is that the code is relevant. For example, add an element, we initialize the list, we add one element, check the length, and check the data inside, and so on. And all steps are roughly the same. So we can play with this. I know that the guys from different projects in GlobalLogic use these tools for test creation in production, because it's saves time. How else we can use? We can use, like I said previously, for parsers. For example, I do not know regular expression at all. I know a little bit theory behind it, but generally I'm not prof in this. And I ask ChatGPT to write a parser for MAC addresses and create tests for it. And we see that it works. We use it in our projects for log processing, where we need to clear its MAC addresses because these codes add variability in our data, in our analysis. How else we can use it? Managers and business analysts can use it for document creation. Our business analyst from my team used ChatGPT to create articles for USA government, not for USA governments, for procedures that necessary for products, and that procedure is written by USA government. And she used ChatGPT to create initial draft of the article, draft of the documentation, and upgraded manually those texts. And this approach even faster than if you create it from the beginning. And one more cool thing is AI for designers. It can create very interesting and cool designs. Maybe many of you heard about neural networks that create UI or code for UI, but I haven't found these examples. They almost all are productionized and keeping secrets, but we can find UI and UX examples open in internet. And almost every image generation neural network can generate you UI UX, so you do not need to have special models for this. I see many Q&A here. If you do not mind, I will answer this question in the end of the lecture. So let's talk about who is AI developer and how to become AI developer. From my point of view, AI developer, it is common engineer in many projects who help to build application and services. This person is responsible for data analysis, AI development, and AI learning. It's responsible for model evaluation to check the quality of the model. And this person should say no if solution if impossible. If he knows that the problem is too complex, and we cannot create autonomous driving algorithm using only one laptop and one CPU and two AI developers. It is impossible. So he should said no. So he should know about the current state of algorithms. A little bit more about responsibility. These guys are responsible for data verification. This is the first step of each project. We need to verify our data. Then we need to create features on what we built our algorithms. We should create machine learning codes and apply model analysis. Let's talk about general task or routine of the AI development. First of all, these tasks related to tabular data analysis. The problem set is very big classification problem. We should answer on question, what customer has no money, who will not left money, who will which person will return the product and so on. The second problem is regression. This is a type of problem where we should answer the question, how many items we will sell, how many money we will own, how many items will be returned, how many cable models will fault in next 1 hour. And all necessary steps here are data validation, data analysis, preparation, training, evaluation, and application. This is the hardest problem among each AI tasks because it contains data analysis step, and it is very hard for tabular data because we have many dimensions. They can correlate, they cannot correlate. We should plot many images here about distributions, about dependencies, and so on. And only then we should train model. And model training here is the simplest part compared to other parts. This is one of the hardest but interesting problems. Other problems, they are hard too, but they hard due to algorithms and model complexity. For example, for computer vision, the data analysis is not the big part. The biggest part is model fits, model creation, and optimizations. In computer vision, there are different problems. They are roughly the same as for tabular problems like classification. Here we should give an answer what is on the image. One more problem is regression, how many items we see on the image, and so on. And two more tasks like detection and segmentation. Detection means that we should mark by polygon, by square the object on the image, and segmentation means that we should draw polygon over the object. And there are many other different problems like SLAM or 3D reconstruction by image or depth estimation, and the solution is also hard because you need many labeled data. Without labeling data, you will not create a good algorithms. What else? Some AI developers prefer to work with natural language processing, and it is different than computer vision because here we do not work with images. Here we work with text, and we need to create text. For example, we need to create a we should create a translation for text. The inputs might be in English, output might be in Russian, in Ukrainian, in Chinese, and so on. It is the same task as text generation. Almost all tasks from natural language processing, almost all tasks are text generation. And almost all tasks, these are fixed, solved by large language models. Three more cool tasks are named entity recognition. I'm not sure that it can be solved by text generation well. There are many cool classic algorithms, and the goal of this task is to extract necessary information from articles about anything. For example, here we see article about Albert Einstein, but in my project we work with clinical information about heart diseases, and we extract information about atrial fibrillations, how many times we observed atrial fibrillations, and so on. And then we use this extracted information in next reports. One cool thing is sentiment analysis. This is very useful for internet stores, for also for social media analysis about happiness of the people by service. And even more interesting tasks is topic modeling, when we should extract different themes from different documents to clusterize them. The situation is very simple. You have many emails in your email, in your post, and you want to answer them all, and you know that there are several common topics, and you want to extract all these similar emails and answer on them just by one question, one answer for all these topics. Necessary steps here are roughly the same as for computer vision and tabular tasks. We need to verify our data set. We need to analyze it, featureize it, fit models, and evaluate models. And from my point of view, it is not it is necessary to check the results manually. Not you cannot believe only on metrics. Even if metric is good, anyway, you should check the result of algorithm manually. And maybe the last type of tasks for AI developer, it is a recommender system and search engines. The idea of this algorithm is next. You have a set of items, books, you have a set of users, and you have observed statistic, which item like or dislikes books. And you should predict for users their preferences or likes or dislikes for different products. And then we use this information for sales or for recommendations. And so if algorithm will be good, it means that we will sell more products. The same situation with purchase returns and preferences. And one more interesting task, it is slightly different than preferences or than a recommendation system. It is a learning to rank. Algorithm roughly the same, but we do not have all set of items. So we have only set of sites in the internet and set of articles, but we do not know the second part. We do not know what user will type. And we need to somehow represent, we need somehow to create algorithm on previous history, but what will be in the future, we do not know. So simple case, if we create ranking algorithm in 2010 year, it will not work today because that data do not contain information about neural networks, about diffusion models, about Gen AI, and so on. So this is a very, this type of problem we should solve maybe each month. We should collect data and fit models, and only in this case, our model will be relevant to nowadays. Okay. Let's talk how to become AI developer. First of all, is motivation. If you do not have motivation, if you cannot motivate yourself, please try something else. If you have motivation, you need to learn mathematics, at least basic of it, just to know what happened with your model or with your pipeline in many different cases, what we should do, what we shouldn't do, how we can make a stable model, how model will not be stable, and so on. And if you do not understand all these formulas, just open Wikipedia, read about them. It will take 1 or 2 days, or open books about calculus, about linear algebra, about probabilities, theory of probabilities, statistics. And then after several months or years, you will understand what happened in machine learning. Why I'm talking about this thing? Because machine learning, it is not a base field of knowledge. It is based on different knowledge, different type of knowledge, like calculus, probability theory, and so on. So if you want to read book and understand book about machine learning, about statistical learning, you need to know the basic words. Please remind how we learn different language or our mother tongue. First of all, we learned the alphabet. We learned how to pronounce collocations, and only then we are trying to read the books. So with mathematics and machine learning, the situation is the same. You should start from learning basics. And the next part, if you have enough motivation and you overcome yourself, just be sure that reading mathematical books is very hard. And if you overcome yourself, you need to learn even more. Learn constantly. Read new articles. Read new solutions from different competitions. You need to compete. Maybe not in public competition. You can compete with yourself. For example, you have a problem. You created a first pipeline. You track your result. And then you think how to overcome your results. It is not necessary to compete with different peoples. Just be sure there are many people who will create code better than you, who create solution better than you. It is normal situation. Just ignore this. Not all problems needed to be done ideally. And what you else should do, you should experiment on your data. You should experiment with your models. Maybe you should create your own models. It is normal when you create custom models, and it works better than public libraries like scikit-learn or standard models from TensorFlow. It is normal. I show a case for my student, and the idea was to create a classifier for data from Kaggle about Titanic. And they showed that the custom bias naive algorithms built on efficient density estimators, it performs better than each standard model than each standard naive bias algorithm in scikit-learn. So with mathematical knowledge, you always can create model better than scikit-learn. So learn, compete, experiment. Let's talk about successful projects that my colleagues worked on, or I worked on them. I do not show all projects from our company. We have we signed the NDA. I'm not allowed to talk about all projects. Some of them are very cool, but unfortunately, I do not have them. So the first problem that we solved in one project is the identification on faces and license plates. The goal was to process data set and create smoother for faces and smoother for license plates, because this might be personal information, and we should corrupt our data and not to represent personal information on data sets. Here you see standard set of problems for computer vision: face recognition and then face corruption. So here we used smoothing algorithms. Sometimes here we should add tracking algorithm. We need to be sure that we clear the same face or clear the same license plate. What else? The line identification. It is very useful for autonomous driving algorithms when we know about lines on the roads, because with line information we know about we know how should car moves, how they who breaks the rules, who doesn't break the rules, and so on. So it's allowed to build more stable algorithms. The problem that I work on today, it is failure monitoring tools for the biggest. Sorry, do you hear me?
Yeah, it's okay.
Okay,
Super.
so some problems with my headphones. Okay. The problem that I work now, it is a failure monitoring tool for one of the biggest telecom companies in the world. And the goal of this algorithm is to find the suspicious logs, split the logs on groups, and when we observe many suspicious messages, we should raise a red flag. For example, here, we split all message on groups, and we know which group contains many suspicious message, and when statistics show big bias in this red cluster, it means that we observe something strange. Guys should do with infrastructure something. And the biggest problem here is not a classification of the logs. The biggest problem is data processing, because the amount of data is so big that we cannot process it in real time. So we need to skip many information and use only interesting or good quality data. And even more, you should know that roughly only 10% of all experiment or 10% of all projects goes to production. It is a normal situation. When you create a good algorithm, you create a good proof of concept. It works. but it doesn't go to production because of many reasons. Because of quality, because of cost issues, because of political decision inside company, and so on. Here I show you top case studies that company works on right now. The Gen AI platform that allows to analyze large document data sets, large language models for driven log analysis. The log guys creates an algorithm that allows to identify the possible issue in autonomous driving. And also, guys, in our team, in our company, works on data augmentation, generation, and synthesis. Unfortunately, I haven't put here a GIF image, but here faces should be different. It is very interesting for media company, for news company who creates news. Okay, let's go next and talk about future of AI for ourselves. Many engineers and many students ask me a question about the future of market, about our jobs and about our work. Many people believe that generative AI will take their work, and probably some people will lose their positions due to Gen AI. Some of them will lose because of spending too much money on Gen AI without results. But it was a joke. But the World Economic Forum tries to give an answer about this question: who will lose their job? If we talk about Gen AI, it started development in 2017 from transformer models, from diffusion models. And what we observe, we do not observe dramatical change in employment rate for last 6 years. We have spike, but probably this spike is the reason of the spike is COVID. But AI development do not have big influence on the whole situation. Situation like pandemic, war have even worse effect on job market. If we open report of the web of the World Economic Forum from 2024, we observe that there are many different problems except of AI generated information, like extreme weather, like AI problems. They are on the second stage. More than half of respondents worry about AI generated content, but there are many problems with political polarization between right and left ideology, between traditional and other ideologies, cost of living crisis, cyber attacks. For Ukraine, it is a well-known problem. It is well-known for Kazakhstan. It is well-known for many European countries. For example, in Ukraine, half year ago, one of the biggest telecommunication service was down for 1 week because of Russian cyber attack. This is not the best experience in our life to live 1 week without a mobile phone. But even more problem with economic downturn, war, and attacks on critical infrastructure. This is worries of the respondent across all the world, and we and they are they worries about AI generated information and disinformation. So I'm not sure that Gen AI will take your job, but it will take job, be sure, in some low qualified positions. At that report, analytics shows us that the current state of the market requires more AI and machine learning specialists, more BI analysts. So we need more analysts, we need more engineers, not always AI and machine learning. For example, Fintech engineers, guys who create algorithms for banks and stock exchanges. We need robotics engineers because robotics not always is about creation human-like robots. It is about gigantic factories where we produce cars, tanks, artillery missiles, and other different goods, like computers. Who will lose their job? Probably you see that probably many clerks will lose their job. Postal service clerk, cashier and ticket clerks, and so on, security guards, software testers, but I'm not sure, shop salespersons. All these guys might lose their work not because of generative AI, because processes are automated and some things can be done automatically. For example, 10 years ago, to fill many documents in my university, I need to print them on paper and write it by myself, by my hands 10 years ago. But now I can do all these things on my laptop. And the situation in different fields are roughly the same. They just need less people to verify human written text, because human become to write documentary in laptops. So the real issue why people lose their job because of the automation, not because of machine learning and generative AI. If we if we read OpenAI article about possible GPT influence on the world or large language models on the world, they tell roughly the same, that if you have a low-skilled job, probably you will lose your position. High position that requires high that requires qualification and enough skilled personnel will not lose versus generative AI. But if you create stupid text in internet that just to fill information for your website, sometimes not stupid, sometimes stupid, they already know that ChatGPT can create text better than copywriters. But anyway, it should be read by people. For example, guys who wrote marketing letters, they know that generative AI can create better the results than they. Or graphic designers can create faster images with generative AI than without it. In our stores, I already see several cases, generative images created by generative AI on food products. And it is very interesting because from on the first sign is okay, but if I look more precise, I do not see little parts on the image, and I, as AI developer, I know that the image was created, and it means that, for example, for designers, some of them might lose their job because the overall performance become better. And maybe, yeah, let's see about the current state of image generation. The current state that humanity can create very photorealistic images. I show you the case from 2016 from the Royal Museum in Amsterdam. Guys from that museum, together with engineer, scanned many arts and create a new Rembrandt work. So they scanned many Rembrandt works and created a new image, a new scene that use style of Rembrandt. That was 8 years ago, and big team worked on that, really big team. In 2022, one guy won the artist competition just using its video card and created image for that competition and slightly changed by his hand. And he won that competition. After this result, when he talked everywhere that he used generative AI was banned on each competition. This image is called Opera Dispatio, as I can remember. So result is great. Previous year, Midjourney released their video generation algorithms, and they are fascinating. We cannot see many details there, but the quality is good, even as good, and we can use it in production. This result is very cool. And after 1 year, it was introduced Sora by other team, by OpenAI, and it creates image with even better quality. And the future of these models is next. We will produce larger videos with more realistic physics, because physics here is learned from the data set. And not all situations are represented in data set. For example, people who walk on the streets, they are well designed. But if you see more precise, let's see what we can see. Oh, sorry, what we can see here. We see a market and people, and we see that people at this table, they are much larger than people from this part of image. It means that algorithm doesn't know about Euclidean metrics. It doesn't know about real world physics. And for better result, we need to take more data. Probably the quality is the issue is in the data. And let me show you the last slide, maybe the saddest slide that describes the overall situation is miscommunication. Maybe 1 year ago, I found the article that instructor was killed by AI. And journalists write it like about the real instructor that was sit in a flying jet. And the decision of AI was to kill instructor, because without instructor, it can do meet the goal of the training. But there was missed one information, that instructor was There was not instructor, and the overall experiment was in simulation. So this was a simulation in some simulator where artificial intelligence can do anything. And that was a miscommunication that real AI killed real people, but it is not true. And this is not a real AI. And this problem can easily be solved just by instructor killing prohibition and so on. So enough qualified AI developer know how to fix this problem. What else I can say about the future? As you see, it is a war scene. And probably more and more artificial intelligence will be used in military. So military companies will use more and more generative AI. They use image generators to make their model stable. These companies already use this technology. They use them for decades. Even when we didn't use neural networks, they used neural networks for flying jet identification and so on. But be sure, more and more flying quadricopters will have AI on their board. And it means that probably AI developers will have more will have more tasks. Thank you for the attention. That's it for now. And if you do not mind, I'm going to answer your questions. Do you see my screen? Do you see questions?
Yeah, thank you, Vitalii, very much. Please go ahead with the questions. And also, I wanted to remind that I can see some participants raise their hands. Please text your questions in the Q&A panel, and we will answer them. Thank you, Vitalii.
Okay. Okay, let's talk about convolutions. There were several questions about convolutions. Sorry, I need to close. Yeah, so what is convolution? Convolution, it is an operation over the image. The idea of it is to take the image and create the different set of different images that based on this one. So it is a processing of one image, and it creates new images that are useful for next steps of the neural network. For example, this image creates new 96 images from the input image, and then next layer create 256 images and so on. So we increase the number of images using the input image. And this new image, they are more comfortable to neural network for prediction. How we can else see what is a convolution? Convolution, it's an operation. Let me show you. Maybe yeah, it's an operation. Oh, this is a good one. Let's see. This is an input image. This is a convolution. We apply it on our image and create a new image. Here you see it. This is the simplest example. Okay, what else? What else? Transformer for text works the same way as in image. They split apart. Those are the tokens they often mention. So let me rephrase the question. Transformer for images works roughly the same as transformers for texts. Yeah, the idea of both of them is split The idea of algorithm is split the information on tokens. For text, it is a word. For visual transformers, it's a patch. Image is split on patches, and then a neural network work with this patch as a sequence. So visual transformers, they really emulate the work of transformer for texts. The question about application of these deep learning models, are they used for video image recognition, computer vision, or another application? All algorithms that I shown you today used for autonomous car driving, for people detection on the image, bicycle detection on the image, item detection on the conveyor belt, and so on. For car detection on the parking. Applications, too many. There are many applications of these algorithms. What are convolutions? Maybe I'm not sure that we have enough time for lecture about convolution. I believe I answered this question previously. Can you, as a PhD in statistics, say that all AI just a set of statistical models? They are just a complex or comprehend easily, and that's why we call it black box. Yes, first of all, it is a black box. And secondly, it is a statistic. So each AI that you see in our world, it is a statistic models, where this data structure is too complex, and algorithm of fitting is too complex, and we do not know why fitting algorithms returns such good model. We have theorems that fit for small models, but for gigantic models, we do not know how they extract features. We know mechanism, but we do not know why this mechanism works. We know only some parts. So generally, AI, it is a complicated linear model from mathematical statistic. Very complicated model, be sure. Okay, all examples from the AI history are the image recognition. Have they tried to work with another type of AI, but not only with image recognition? I decided to talk about image recognition because it is very simple for people to describe, because it works with images, and we can show many images. What about other types of AI? If we work with tabular data, we use different set of models. For example, pit-neural networks. We use gradient boosting and tree models, and split our multidimensional space on polygons and try to emulate and try to efficiently predict situation in small polygon. But visualization is not the best for big auditory. Okay, is the problem of optical character recognition considered solved too? Optical character, what are some good OCR tool? Probably I do not understand what do you mean about optical character. Maybe you talk about text. Yes, this problem is also solved. There are many good tools like Tesseract. Tesseract open source OCR engine by Google. This is the best one. But be sure there are many of different. Okay. Question to the speaker: is it possible to get PhD in mathematics by doing AI research? No, it is not possible, because machine learning and AI research are not truly the science. It is a practical part of science, but mathematics and statistics and machine learning, they are different part of science. If you want to become good AI developer, you need to learn mathematics, not only machine learning or related themes, AI related themes. By the way, AI research might be a result of your science. So the process is next. You read mathematics, you write PhD, and then found that it is applicable for machine learning. This is the right way. The opposite way, when you have machine learning problem and you create a model for it, not the best. It is not the best way to become a PhD. But other PhD or other lectures can give you different answer, I think. What do you think? Will copilots become autopilot for next year, or it will need still the human interference? It is still need human interference. I'm not sure that you mean about copilots as autopilot. It is very dangerous to create their code. The problem that all this model have auto-regression problem. So with the high probability, it will reproduce their own code. And it is not allowed, it is impossible for this model to create something new. Almost all things that we see in ChatGPT or Copilot was taken from examples. And this model are fit to be near that examples. So new concept should be created by human. So I have doubt that Copilot will become fully automated. Acquisition about practice. After we see live coding part, we get something like home task. I'm not sure about home task. I do not have, maybe not for this session, because my goal is to tell you about the current state of machine learning, about current models.
Thank you, Vitalii. And I would like to mention that we are almost out of time, but if you have some more minutes to answer all the questions, and then please go ahead. And just I wanted to announce to our participants that if you don't have enough time, because we are aware that we announced 1 hour and a half, then you can listen to answers to the questions later in the recording. But who is interested, please stay and continue. Thank you, Vitalii.
Okay, I think I can answer 5 or 10 questions and then we should stop.
Great.
Oh, the question is next. Why hallucination occur in the large language model? This problem occurs not in the large language model. It occurs in every Gen AI algorithm for image generation, for GAN, for diffusion model, for large language models, and so on. The problem is that sometimes it returns a token, or it returns output that have very small probability. And this situation occurs too frequently. I'm not capable, I cannot say why it is happened. I can say just a buzzword like black box, we do not know. We only have theorem that it is universal approximator and so on. But general answer on this, because it is happened, because algorithm is not smooth enough. Okay, let's go to next question. Maybe the possible answer on this question, why it happened, will be because we have a small data set. Maybe with bigger data set, the quality become better and better without hallucinations. Do you use commercial version of ChatGPT for production code generation? No, I do not use. It is prohibited us to use ChatGPT, and commercial version is not open for me, but I know that some guys use Copilot. For some projects, Copilot, commercial version of Copilot is allowed. Is it really cheap that to do by developers? I do not know. Guys still continue the development, and evaluation. Answer will be soon. I saw articles in local newspapers that some companies decrease their code development on 20%, from 12 to 20%, just using generative AI. But I do not have statistics from our company. Okay, the next question. Hello, I want to ask about libraries. If you want to be an AI ML engineer, you have to know TensorFlow and PyTorch to the same context or not? No. If you want to be a researcher and create your own neural networks and make a research, probably it's better to use PyTorch. If you want to use models in production and create a really stable production algorithms, stable with good documentation, you should use TensorFlow. It is more production ready than PyTorch. PyTorch is a low level framework for investigations and research. Done. What type of issues do you usually have with data sets? Could you please name typical problems for image data set and for the text data sets, how they are solved? For text data sets, there are many problems like encoding problems. Some texts decoded differently in Linux and in Windows because different users uses different operation systems. They can use they might use not common encodings. For example, some guys do not use ASCII, but use Cinderil. Yeah. Cinderil from oh no, I cannot see now. It's not this one. The language from the Lord of the Rings and sometimes it can be a problem when people do not use common encodings. And problems with image dataset, corrupted images, artifacts on the images. For example, mistakes when accessor tells that the human is in the image, but we see a car. Sometimes corrupted image not by a mistake. So many people write wrong answer because they want to do this, because they receive good emotions by corruption. Oh, many errors. How can artificial intelligence help in the work of 3D artists, and what type exactly? Maybe some type of an icon improves the render. I know that 3D is not well developed scene in AI because of big complexity. To represent 3D image, we require more data. We require more data sets, and data set for 3D, they are bad. They are small, quality is bad, they are different. So the real problem is data set here. How we can use 3D models. Guys from our team created a PSC that allows them to create a 3D scan using AI. So the idea was to make a photo of jewelry and create a representation of 3D rings or earrings and so on. In this case, it might help you. but sometimes quality might be bad. What audience level is this IE marathon designed for? Is it suitable for someone who isn't familiar with the subject? We developed this course, this AI marathon for students who know something about mathematics. But other guys are invited to. Can you recommend some books, sites that explain basic notion in AI? I can recommend you books Hasty, Friedman, Tibshirani, Elements of Statistical Learning. Elements of Statistical Learning. This yellow book, it is open. The yellow one. Let me put this in the chat. It tells you about the machine learning from the beginning, from the entry. What is it about variables, terminology, and so on. It is not a mathematics style book. It is it is useful. It is very good for people who do not know mathematics, because not always you need to understand what is represented here. The more important to read article. Let's continue. Sites. There are many sites in Medium. Just Google. Just Google. Oh yeah. What else? Kaggle. If you want to know about Kaggle. If you want to know about machine learning, probably you know the Kaggle. This platform for competitions, and there are many basic examples, basic data sets for learning. And here you can open many codes, many notebooks, and read. And this is a tutorial that tell you from the beginning what it is, the data set, how to work with it, and it might give you the first understanding about AI and machine learning. Let's continue. How do you process the statistical data? With which mathematical method? And how do you obtain the accuracy and the errors? The process is quite standard. We need to display his distribution of the data, to see correlations, maybe drop some data, find abnormalities. Mathematical methods, there is no standard way. You need to try as many as you know. How to obtain the accuracy and the errors? How do you obtain the accuracy? Good accuracy we can obtain by using ensemble of neural networks and gradient boostings. This is the way how to obtain the best quality of the model, at least for tabular data. For images, maybe only neural networks ensembling, and for text too. Oh, I'm seeing only 15 FPS per second. This broadcasting. Is it supposed to be like that? No, it is not supposed to be like that. Probably we need to investigate the issue. Do we see near future AI models that develop new AI model architecture and so on? I do not know about this. I'm not sure that we will create AI models that will create new AI model architectures. We can create a method that can suggest us new architectures, but truly AI cannot do mathematics. And while it cannot do new mathematics, it cannot create new models. One guy asked me about Linux Ubuntu operation system. I'm not going to answer this question. I do not know which distribution I'm using. Why hasn't AI read us of spam yet? Why AI is not efficient to overcome the spam? Because some spam messages, they are very tricky. They contains abnormal characters. Some spam generator creates text with high. Spam generators they fit to overcome spam filters. So truly speaking, it is well-known problem when you can replace characters by the analogs from different alphabets, or if you can replace words on synonyms, and algorithm will give a wrong answer. So we have this problem. We have the problem of spam because fraud is very flexible. Because many people who create spam filters, and there are many people who create algorithm for spam generations. And this is maybe not balanced. This is a competition. Oh, let's go next. When you say that quadrocopter will have AI on board, is it means that there will be an algorithm previously produced and trained by ML and installed to the quadrocopter, so it will not be trained during a resulting flight? Nobody fits algorithm at production. No, it means that guys created algorithm in simulated environment, placed in quadrocopter, and then they use it. So this means that nobody fits algorithm in production. It is very dangerous. Any example of AI used in cybersecurity? If you use email, it means that you use AI, because each mailing service have AI inside that filter spam, malicious messages, and so on. And that when you see spam, it means that you see only small part, maybe less than 1% of spam that produced. So many services really make safe environments without spam. So they just now you see mainly extremal cases. How AI can use in cybersecurity to, for example, to find abnormalities when guys guys without access use keys in different services. This is a very common case when keys for services, I mean SSH keys, they are shared among different developers, and sometimes AI algorithm can raise a flag when the activity is suspicious. How can AI models, which are typical based on the assumption of uniform distribution, make errors? How can? What happens when these models encounter black swan, even as disabled by Taleb? I'm not sure that all neural networks and all models use uniform distribution. What do you mean by uniform distribution? It may be interpreted in many ways. Data might have uniform distribution, or outputs might have uniform distribution. Weights inside might have uniform distribution, and so on. Errors, it's normal. If you work in paradigm of AI and ML, you need to take in account that the make the AI without error is impossible. It is a part of AI life. What happens when these models encounter black swan events? Each artificial intelligence algorithm can behave unexpectedly. It is well known for models which have unbounded activation function. So if your model is unbounded, you might receive extremal results. If your model is bounded, for example, like neural networks with bounded activations or gradient boosting, it means that you will obtain only results from your data set. But if you want to create something new that you cannot obtain from your data set, in this case, you need to have unbounded activations, or your function will be unbounded. And probably this unboundancy is an issue of the hallucination of the neural network. So the issue is, so the hallucination is a result of unboundary, of the situation when you want to receive something new that's different from your training sample. Last for question, and I think we will stop on this. Question about neural networks and connection in our brain implants. Is this really already possible, or is this just information stuffing? State of the art and new implants that bionic implants, they use neural networks right now. So this technology is implemented, and so guys from our company work on some POCs for implants for guys without hands and legs. So this is not this is not an informational stuffing. This is not a buzzword. Maybe if we talk about heart implants, like implants in brain, implants in eye, it is very hard problem. I'm not sure that it will appear in nearest year, but implants for hands, it is a reality. What skills should have AI developer to receive their first job? What skills should have? AI developer should capable to write code, at least at Python. He should know libraries, different common libraries for this topic. He needs to practice. If you have several simple but well done solutions for your problem, your own problem in your house, or for some problems in Kaggle, it might be enough. You need to know about data. You need to research your data. You need to know how your decision will influence on the model, and so on. And also, you need to describe the result of a model to interviewer. So you should have enough good soft skills to describe your solution to other guys. How researchers estimate required NN complexity, number of inner layers for their task? Trial and errors. Yes, trial and errors. You do not know which model will fit your data. The right answer can be obtained by many trials and errors. Tens, dozens, a couple of dozens, hundred trials, and only then you know what is good for your problem. will we have a brief overview on liquid neural network uses a smartphone? I do not know what is this. I will type with neural networks. I will read about them, but differential equations. It seems like Spike. No, we are not. I'm not going to tell about this model. This is more. This type of models are more interesting for researchment than for application right now. Stochastical differential equations, as I see it here. Maybe do you have a list of educational materials that can be useful for beginners? I suggest you to start from book Hasti Friedman Tipshirani that I typed previously, and you can open MIT courses or Stanford courses from deep learning and machine learning. They are very good. But please read books. Thank you. I do not have more questions. I think we should start. We should stop here.
Thank you very much, Vitalii. Yeah, it was a bunch of questions, and I thank to all of participants. Yeah, we were really a little bit out of time because a lot of questions and interesting topic.